Earth's shaking giants. Why we need to understand earthquakes. Earthquakes are a powerful reminder of our planet's incredible forces. They can be scary, but understanding them can help us stay safe. By learning the basics of earthquakes, we can be better prepared when they happen. This knowledge empowers us to protect ourselves and our loved ones. Earthquakes happen when the Earth's crust suddenly shifts. This release of energy causes the ground to shake. These tremors can be felt miles away from the source. Understanding the science behind earthquakes helps us to appreciate their power. Knowing what to do during an earthquake is crucial. It can save lives. By following simple safety tips, we can minimize risks. Preparation is key to staying safe during these events. This essay will guide you through the basics of earthquakes. We will explore how they form and what you can do to stay safe. Let's delve into the world of earthquakes and learn how to be prepared. The science beneath our feet. How earthquakes happen. The Earth's outer layer is not one solid piece. It's broken into several large pieces called tectonic plates. These plates are in constant motion, although very slowly. Imagine a giant jigsaw puzzle with pieces that are always shifting. The movement of these plates is driven by heat deep within the Earth. This heat causes the rocks in the Earth's mantle to flow slowly. This flow creates currents that push and pull on the tectonic plates. As these plates move, they interact with each other. Most earthquakes happen at the boundaries of these plates. They can collide, pull apart, or slide past each other. This movement builds up stress along the edges of the plates. When the stress becomes too great, the rocks break. This sudden release of energy causes vibrations. These vibrations travel through the Earth's crust and cause the ground to shake. This is what we experience as an earthquake. Plates in motion. The constant dance of Earth's crust. The Earth's tectonic plates are constantly on the move. They move very slowly, only a few inches a year. This movement is barely noticeable to us, but over millions of years it has shaped the continents and oceans we see today. There are three main types of plate boundaries: convergent, divergent, and transform. At convergent boundaries, plates collide. At divergent boundaries, plates move apart. At transform boundaries, plates slide past each other horizontally. Each type of boundary creates different geological features and earthquake patterns. Convergent boundaries are known for mountain ranges and deep ocean trenches. Divergent boundaries create mid-ocean ridges and rift valleys. Transform boundaries are known for their strike-slip faults. Understanding the different types of plate boundaries helps scientists predict where earthquakes are most likely to occur. By studying the history of earthquakes in a region, they can identify areas of high seismic risk. Fault lines: cracks where the Earth gives way. Fault lines are cracks in the Earth's crust where rocks have moved past each other. They are found at plate boundaries where the stress of plate movement is concentrated. Faults can be hundreds or even thousands of miles long. When rocks along a fault line suddenly slip, an earthquake occurs. The point where the slip begins is called the focus or hypocenter of the earthquake. The point on the Earth's surface directly above the focus is called the epicenter. There are different types of faults depending on the direction of movement along the fault plane. Normal faults occur when rocks are pulled apart. Reverse faults occur when rocks are pushed together. Strike-slip faults occur when rocks slide past each other horizontally. Fault lines are like scars on the Earth's surface, marking areas where the crust has been broken and reshaped by earthquakes. By studying faults, scientists can learn about past earthquakes and assess the risk of future events. Section 5. Seismic waves. The energy that travels through the Earth. When an earthquake occurs, the energy released travels through the Earth in the form of seismic waves. These waves spread out from the earthquake's focus in all directions, kind of like ripples in a pond. There are two main types of seismic waves: body waves and surface waves. Body waves travel through the Earth's interior, while surface waves travel along the Earth's surface. Body waves are faster than surface waves and arrive at seismographs first. Surface waves are responsible for most of the shaking we feel during an earthquake. They cause the ground to move up and down and side to side, which, well, can damage buildings and infrastructure. Seismologists use instruments called seismographs to record seismic waves. By analyzing seismograms, they can determine the location, depth, and magnitude of an earthquake. Section 6. When the Earth shakes. Staying safe during an earthquake. Earthquakes can happen without warning. Knowing what to do during an earthquake can make a life-saving difference. The key is to stay calm and protect yourself from falling objects. If you are indoors during an earthquake, drop down to your hands and knees. This will prevent you from being knocked down. Take cover under a sturdy piece of furniture, such as a table or desk. Hold on to your shelter until the shaking stops. If you are outdoors, move away from buildings, power lines, and trees. These can collapse and cause injury. Find an open area and stay there until the shaking stops. If you are driving, pull over to the side of the road and stop. Avoid stopping under bridges or overpasses. Stay in your car until the shaking stops. Section 7. Drop, cover, and hold on. Your first line of defense. The drop, cover, and hold on method is the safest course of action during an earthquake. By dropping to the ground, you become a smaller target for falling objects. Covering your head and neck protects your vital organs. Holding onto your shelter prevents you from being thrown around. If you are in bed during an earthquake, stay there and cover your head with a pillow. Only move if you are in danger of falling objects such as a light fixture. Stay away from windows, mirrors, and other glass objects. These can shatter during an earthquake and cause injuries. After the shaking stops, be prepared for aftershocks. These are smaller earthquakes that can occur minutes, hours, or even days after the main shock. Section 8. After the shaking stops, navigating the aftermath. Once the earthquake has stopped, check yourself and others for injuries. If anyone is injured, seek medical attention immediately. Be aware of your surroundings and potential hazards such as broken glass or fallen power lines. Be prepared for aftershocks. These smaller earthquakes can cause further damage and injury. Stay away from damaged buildings and structures. Listen to the radio or television for emergency instructions. Follow the advice of local authorities and emergency personnel. If you are at home, check for gas leaks, water leaks, and electrical damage. Turn off utilities if necessary. Section 9. Be prepared, stay safe, earthquakes, and your safety plan. Earthquakes are a fact of life in many parts of the world. By being prepared, we can minimize the risks and stay safe during these events. Create a family emergency plan that includes evacuation routes, meeting places, and important contact information. Prepare a disaster kit with essential supplies such as food, water, first aid kit, and flashlights. Secure heavy objects in your home such as bookcases and mirrors. This will prevent them from falling and causing injuries during an earthquake. Learn CPR and basic first aid. This will allow you to help yourself and others in case of emergency. By taking these simple steps, we can all be better prepared for the unexpected. Remember, knowledge is power when it comes to earthquake safety.